Hi everyone, and welcome to another update on the Spectrum game tool. Some of you may have noticed that I released a very short teaser video last week that just gave a hint as to what was coming in the next update. The reason I did that is because I knew it was going to be longer than a week to get this video out. There was more work that I could do in the time I had available. You'll have seen, if you've seen that video, that the work is around things like bullets and basically the ability to spawn and create new objects dynamically during the game, be that bullets or objects that you might collect or things like that. And it took a little while to get the implementation plan together. I had to think a little bit about how optimization would work, how performance issues would affect the choice of methodology, and it involved a lot of experimentation at the C level before I even got into the engine and working out into the tool, and working out how to make the tool generate the code necessary. Just writing the code in C to make sure that it could actually be done. And that's what you saw in that teaser video. It was hand-coded C rather than anything that was generated by the editor. And once I'd proven that would work, I then started working on the actual editor itself to make it able to generate the new code that was required to use those features. It's touched on a lot of areas. A lot of things have changed and improved. Things that I knew that would happen at some point, but they've been a bit accelerated, or the timeline's been a bit accelerated by the choice to go down this route. So it's going to take a little while to go through them, so I'll start right away. Bring up the editor. Also experimenting with a slightly different way of producing these videos, so you'll get to see my face for one, and a slightly different way of producing them. Let me know if you like it, or if you'd rather I went back to the old way. So looking at the editor, not too much has changed. There's some visual improvements. This sprite sheet here is new, but if we look at some of the things that already existed, you'll see that I've done some work to make it clearer what each element within each tab is. Each area has its own header now, which gives some description, and it's a little bit more organized. So for example, in the rooms, the assets are all collected into one section within the editor. The lists up here, and they each have their header that describes what's in them, and it's the map as well, assets and objects, just to make it a little bit cleaner and easier. Excuse me. So on to the main changes. So one of the things I discovered as soon as I started experimenting with the C side of it, was that doing everything with large sprites, large masked sprites in particular, just wasn't going to fly. It became too slow too quickly. Slowed everything down, became really problematic. So I knew I would have to have some mechanism for creating different sized sprites, so this was the right time to actually bring that in. So where we had one sprite sheet before, it was all 16 by 16, we've now got this additional feature here that allows you to create different sprite sheets, and I'll show you how that works very quickly. So as before, you create a sprite, you draw in here, nothing's changed there, it's a 16 by 16, and the mask still works exactly as before if you've got mask mode on, which I'll get into in a moment. But then you can add a new sprite sheet down here. This one's defaulted to 8 by 8, so you see the pixel grid has changed to an 8 by 8 pixel grid, and if we create a sprite, it creates an 8 by 8 sprite that we can paint as normal and swap between them quite happily. Now you'll notice that in the new sheet the mask button is disabled, and that's because mask is not, this sheet hasn't been configured to support masks. This gives you some control over the amount of data that gets exported, because masks obviously double the amount of data that gets exported for a sprite sheet. If you're not using masks, it's better just not to have them. So we've got this edit button down here, which brings up some properties for the sheet: size, name, and the mask button, which I'll go into in a moment. But let's have a look at the sizes. So this one is 8 by 8, as I say. Each dimension, width and height, can be any multiple of 8. I've limited it up to 32 in both directions, just because it seems like a reasonable limit for a single sprite on a spectrum. Please do comment in the comments below if you think that should be different. And they don't have to be the same. So I can create a sprite sheet. I can modify this sprite sheet to be 8 wide by 16 high. If I do that, it wipes out any sprites. There will be a warning, and everything adjusts. So the pixel grid adjusts aspect ratio to make sure the pixels are still square, and you can still paint in it in exactly the same way as you did before. And these become the correct aspect ratio over here too. And that carries on through all the editors. So if we go to the object editor, the other change that you'll notice here is that you've now got the ability to choose which sprite sheet for an object. So if we create a new object, it will default to the main sprite sheet, the first sprite sheet, but we can switch it to the different one. It'll wipe out any frames because the sprite sheets are different, so it has to clear that out. And you can create frames and assign them from the new sprite sheet quite happily. Different multiple frames. And you'll notice also down here there's a slight few additions in the properties. It used to be just the name of the object, but now you've got the draw mode, which lists the way that the sprite or the visual that represents the object can be drawn to the screen, as I mentioned before. There are 4 different modes: load, OR, exclusive OR, and mask. Load just wipes out whatever's in the background, takes no notice. OR and XOR do the obvious OR and XORing of whatever is in the background, and mask will use the mask. In this case it's not available as a choice because the sprite sheet for sheet 1 has no mask. So if we go back to here and create another object and leave it on the main sprite, then mask becomes an option for the drawing mode. That means you have the ability to use the same sprite data, the sprite bitmaps, in different ways depending on the object. So you could theoretically use a sprite sheet like this one that does have mask data and render it using exclusive OR, ignoring the mask effectively. That brings you some performance improvements. The drawing is much faster if you're doing exclusive OR and there's no masking of the background data, but it just means you can reuse the data in different ways if you wanted a particular sprite to be used in a scenario where masking out the background wasn't important, and exclusive OR is perfectly okay. Then you can enable that for that use of the sprite. Continues on into rooms as well. So if we create a room quickly, you've got the objects down here that can be drawn. For some reason these objects don't always update at the moment. I'm looking into that, but everything else is fine. So let's just quickly create a tile so that we can draw something in the map, or in the room, sorry, so that when we come to the map we can see something in here. If we bring that in, same thing applies here. The sprites are all adaptive to their correct size according to the sprite sheet, and everything works fine there. There's one other thing you may have noticed in here, which is the dynamic count here. Now, one of the things I discovered when I was doing the C work was, in order to maintain performance, it was necessary not to be allocating memory. While the Z88DK and the SP1 library in combination do have some memory allocation, dynamic memory allocation capabilities, it felt like that would be too much of a performance hit to use. So I took the decision, for now, it can be reversed if necessary, but for now you define ahead of time how many dynamic instances of each object are available. So at the moment neither of these will be allowed to create dynamic versions because they're all set to 0, and you can set this to as many as you like. I think I've limited it to 10. There's an additional limit that's placed on the use of dynamic objects, which is the total number of dynamic objects in the game itself. So for example, you could have 10 different objects, each with 5 with their dynamic limit set to 5, but still only set the total dynamic count to be 10, which means you can only have 10 of any of those those objects, up to 5 of each. So you have to understand those limitations ahead of time. Excuse me. When you're designing your game. At the moment, there's no way of changing that global dynamic limit, but it will be put into a game level settings area as and when I get to that point. So that's the majority of the changes. A couple of other cosmetic changes. I was getting very frustrated with the fact that when you zoom in any of these, the map or the room, it would zoom into the top corner because it was just changing the zoom value. So I've put in some code to make it zoom on the mouse, which makes it a lot easier to navigate. And the same with the map. If you zoom in, it zooms in to where your mouse is and out to where your mouse is, which makes it a lot easier to work with. Nice little things, but nothing big. I think that's mainly it. We've got the mask. I've covered the different mask modes of the sheets. I've covered the different sizes and so on. So let's have a quick look at what this means. So if I load up the standard game demo, we've got our objects. I've added a new object. In fact, if I go back to sprites first, we'll see that we've got 2 sprite sheets, and this one is an 8x8 which just has the bullet in it, the bullet sprite, and it's no mask because it's going to be used for exclusive or only. So if we go and look at the objects, we've got the bullet. It uses sheet 1 and it uses an XOR mode. Now at the moment this is set to 0, so it wouldn't be able to actually dynamically instantiate any of the bullets. But if we have a look at the code that's generated, it'll give you an idea of how it works. So at the top here we've got our initial sprite sheet, which is the 16x16 with masks, and we've got a bunch of sprites in there. And then we've got a secondary sprite sheet, which you can see is much simpler. It's 8x8 with no masks. So this is where the optimization in terms of memory use comes from. And then we've got a bunch of stuff, and then we've got our object definitions. These are all dynamic now based on the creation of the sprites and the type of the sprites. All this data is calculated based on the sprite sheet and the settings in the object. So you can see this one's using mask and it's using 2 bytes per, which is including the mask and the mask drawing mode. And then if we pop down to our bullet, you see this is using the XOR mode and 1 byte per row column, and there's only 2 columns defined. There's a very simple always applied to the bullets, so every time it comes around it will just move it to its current x plus 5, which in turn sets x back to the new value, so it just moves it fast across the screen, 5 pixels per frame. Now if we go down to the bottom, so actually if I go to where that was again, you'll see there's nothing else changed here. There's nothing added afterwards. Note that for a second. And then down at the bottom we've got some extra data for for the dynamic object management stuff. So we've got a table of dynamic object references, which is null for all because all of the 4 objects have been set to have no dynamic object count. And then we've got these 2, which is a dynamic object table, which is the table of currently it's currently active dynamic objects up to 10. That's the limit I said. And then we have these slots, and this is a very simple table mechanism used to define which entries in this table are currently active. So every time a new dynamic object is created, a 1 will be placed into here, and when it's removed, because you can delete dynamic objects as well, it will be returned to 0, which means it's free to be used again. So it's just an easy way of tracking which are in use. So now if I go back to the bullet and I set this to 5, for example, and regenerate the code, first thing you'll notice is that there's an entry in here now, the dynamic definition for bullet. So the system has recognized that the bullet is able to be dynamically instantiated, spawned. And if we pop up to the bullet, if I can find it, where are we? Yeah. So after the code, the methods, we have this structure created again. It's a similar style to the in terms of allocation, in terms of how the memory is tracked to the dynamic objects at the bottom. So you have up to 5 of the structure that defines what a bullet is, which in this case is a very simple structure. It's just a sprite reference. And then you have these slots again, which is the same mechanism. It'll put a 1 in there when 1 is allocated, and when it's deleted it'll set it back to 0, making it available for use again. And this is just a simple definition which is used by the rest of the engine to manage the data in these structures. Just the maximum count, pointer to the storage of the slots, which are these two, and the data size. The data size is necessary because internally the data storage is a void star. It's a pointer to just undefined type memory, but it needs to know how big each entry in this data array is. So we store that there. So that should mean that it's possible now to dynamically allocate up to 5 bullets. And if we look at the logic for bullet, if we look at the logic for player, this has been modified slightly with a new node. So we got the jump fire button goes into another always here, and if it's 1, if it's not 0, sorry, it will spawn an object of type bullet at the player's XY. So it's nothing clever, it's just wherever the player is, it will put a new bullet there. And because the bullet code has the always move 5 pixels ahead, as soon as it's spawned it will start flying across the screen, in theory. So if we export this, and hopefully if everything holds together, you should be able to see the effect of all of this in play. So that's exported now. If I switch to the shell and compile it, it's taking a little bit longer now. Obviously with each new feature and new additional change, it's a little bit bigger and therefore taking a little bit longer to compile, but it's still manageable. Once that's finished, we'll go to the emulator and see if it all works. There you go, that's compiled. Switch to the emulator and load the new tap file. It should look familiar. The only difference or new thing that you can see at the moment is this up here, which is just some debug. It's basically a count of the current number of dynamic objects in play. Everything else is working as normal. Collision with the background and so on is all effective. And now if we hit space, we get bullet fires. I need to put some code in to debounce the space because it's very easy at the moment just to fire off all 5 bullets very quickly, but that should be fairly straightforward. The objects that are created spawned via the spawn node are spawned as global objects. They're not assigned to any particular room, and there's some hard code in there at the moment that just removes them, kills them as soon as they leave the screen. So it'll work in any room, and that's basically what it's doing at the moment. So I think we're getting a little bit closer now to something that can actually generate a game or something that might be vaguely playable. That was a major step, and it opens up a lot of new functionality. There's a few more things I need to get in. I want to get some concept of animation. So if we go to the animation for here, you can see I've got the ability to add multiple frames and it will store. So if I add multiple frames here, I can put whatever I like in those frames. It will store the references to the sprite sheet in the object, but there's nothing in the logic at the moment that allows you to cycle between them to do animations, which I think is a critical, or not just animations but state changes. So for example, we could have the minor character in here pointing in the other direction and switch depending on which way you're facing. So I need to put that in next, and a couple of other things, and hopefully I think we're getting closer and closer now to something that could be used as an early access pre-alpha. So as I mentioned in the last video, I have set up a coffee page where I'll be tracking all of this, all of the messages, updates and so on will be going to that page from now on, just to keep it all in one place. The videos will be going onto YouTube, but referenced from the coffee page, just to keep it all clear. So if you want one place to keep track of what's going on, that's the place to look, and that'll be where I'll be arranging the early alpha access test. So if anyone's interested, pop a comment below or ping me on the coffee page, and I'll put your name down for consideration. Okay, thanks for joining. Do remember to subscribe and like if you like, and comment below, and I'll see you next time.